Okay, friends, two more problems, two more examples. And again, I'll have the paper posted online for my class and other people who are following on YouTube. Cool. Thank all two of you for watching. So, running with the same k value of 0.012, meaning small k, forward reaction not very favorable, reverse reaction very favorable, not a lot of products getting made. So, at equilibrium, 0.52 molar ammonium and 2.6 molar hydrogen gas, how much nitrogen gas we got? So always start by writing your equilibrium expression, products over reactants. Ammonium squared over the product of nitrogen times hydrogen gas cubed. So let's plug in what we got. 0.012 equals 0.52 squared over nitrogen gas times 2.6 cubed. So let's do a little bit of algebra and rearranging of terms. If you multiply both sides by nitrogen gas and N2, 0.012 times nitrogen gas equals 0.52 cubed over 2.6 to the third. Well, now let's get the variable by itself. Well, if you're going to do that, divide both sides by 0.012. Well, that gives us our next step. N2 now equals 0.052 squared over 0.012 times 2.6 to the third. Oh, well, when you punch all that into your calculator, and I'm not going to write all the numbers out for you, the concentration in nitrogen gas works out to be about 1.3 molar to two significant figures. That's not so bad. So you can see how to manipulate and rearrange things here. That's pretty good. Last problem. Made the last video a little bit long so we could get through everything here, guys. Okie doke. So, still running with the same K. And on this one, I wanted to do this a little bit to make sure that you could get through a cubed root. So I showed you how to solve for a K and then how to solve for each one of these variables. I'm a nice guy. Don't worry, I didn't let it go to my head. So, at equilibrium, your ammonium concentration is 0.44 molar. Your nitrogen gas concentration is 2.2 molar. Solve for hydrogen gas. Start out with your equation. Products, reactants. If you had a coefficient, take care of it. And so remember, it's N2 plus 3H2 over turning into 2 ammonium gases. So you don't think that I'm crazy because I didn't show it on the last one. There you go. Well, plug in what you got. 0.012. On top, well, your ammonium's 0.44 molar. That's going to get squared. Your nitrogen gas is 2.2 molar. That's to the first power. It stays by itself. Hydrogen gas is getting cubed. So on this one, I think it's easier. If I multiply each side by 2.2, well, that gives me 0.0264 times hydrogen gas cubed. Well, and then if I do 0.44 squared, that gives me 0.1936. Okay, well, divide each side by 0.0264, and that gives me my variable cubed by itself. So there you go, 0.1936 over 0.0264. Well, let's get that number. And that was really interesting. I didn't design the problem to be this way. It gives me hydrogen gas cubed, gives me 7.3 repeating. So if I take the cubed root of hydrogen gas and the cubed root of 7.3 repeating, that will give me the correct answer. And that turns out to be about 1.9 molar. Some calculators don't come with a cubed root function. And so what you wind up having to do is take 7.3, and you can, if you had the answer button, you could have done 7.3, or you could have done 7.33, and then if you hit the little caret button, use your parentheses and do it to the 1/3 power. And that will do the same thing for you. If you wanted to do the square root and you can't find your square root button or it doesn't have it, take 7.33, hit the caret, parentheses, and do it to the 1/2 power, you'll get the same thing. So that's your workaround, okay? 7.33 repeating, or 7.3 repeating, hit your exponent button, your little caret, parentheses, 1 divided by 3, end parentheses, and that will give you the correct syntax. And that way you don't waste time searching for this, okay? So no matter what, you've got the correct method now for solving all of this, okay? Got one more thing to go through, and that's equilibrium by Rice tables. And then we're going to move on to acid-base stuff.